This is a summary of my DevOps and Agile Infrastructure presentation at Confoo 2015. My name is Will Stevens and I'm the lead developer at CloudOps. I'm a CloudStack committer and PMC member. CloudOps is a Montreal-based company and we have customers all around the world. We focus on building and operating clouds. We have created and operate cloud.ca, which I'm sure that you will hear a lot more of in the next little while. This presentation was given to a room of developers, so it will be very developer focused. Agile infrastructure and DevOps are very important for developers in the near future, and developers are going to play a huge role in how effective infrastructure is used in the near future. DevOps basically is the ability to automate your infrastructure with software. This gives you a lot of benefits in terms of repeatability and flexibility, and it also gives you a much quicker turnaround time on your development cycle. So this gets your security fixes out quicker, and it also lets you automate testing in the process of your development process. Agile infrastructure is basically the ability to manage your infrastructure through APIs. This makes things a lot easier for being able to automate your deployment process and everything, because you can spin up the machines and the resources that you need on the fly, which makes it much easier to be able to have an agile workflow for your development process. Some of the key components here are being able to self-service, so that a dev team doesn't have to depend on their IT teams to get infrastructure in place to be able to actually solve the problems that they need to solve. By pooling the resources and actually having all the resources together in essentially one system, it makes the operations of this much easier as well, because you are treating all the infrastructure as one set of infrastructure. So you don't have like one-offs of infrastructure in part of your data center and different one-offs in other parts of the data center. You basically have all your infrastructure working together to basically have a cohesive infrastructure that is operated by a team, and they understand how it is operated. So it makes the operational cost from a manpower and understanding how all the different systems work. It brings that cost down, but it also brings down the cost of the infrastructure as a whole, because by pooling resources, you don't have machines just sitting there idle, not doing anything. So why is this important to developers? This is important because developers are really the ones who are going to be developing the code to be able to build this automation. They'll be the ones who are developing new integrations for the automation, as well as developing the code itself that needs to be put out into the infrastructure. I expect developers to play a major role in the DevOps space in the next year. So let's get to some of the more practical stuff. Here are some of the different softwares that we use and are common in this type of space. CloudStack in this case is allows you to orchestrate and manage your infrastructure. Jenkins makes it easy to build, test, and deploy code. Test Kitchen basically lets you test your infrastructure as if it was code. Chef lets you manage the configurations of what is being installed on your systems in a very meaningful way. And Fabric probably shouldn't be in this list, but this is what got me into into DevOps, and I still have a love for Fabric, so I'll touch on that later. So Cloud Stack, basically, it is an infrastructure as a service platform. It is multi-tenant. You can share resources between teams and groups of people. It allows you to spin up new virtual machines, network storage, and that sort of thing. And everything is controlled through an API, or can be controlled through an API. It has a UI as well, obviously. Um, it is open source and actively developed, and it's a pretty good option if you are looking for cloud orchestration to be set up in your data center. Jenkins is kind of a Swiss Army knife for basically development and operations. Um, It will integrate with code repositories to be able to pick up code changes that are pushed to code repos. It builds a variety of languages. It can run all sorts of different test suites. It can run code analyzers. Um, it can push push artifacts to either a web server or over SSH. It can build your packages into deb files and RPMs and such. And if it doesn't do what you want it to, you can probably make it do what you want with their plugin extensions. So Test Kitchen, basically what it does is it allows you to run, to set up your infrastructure and then test it to make sure that the infrastructure that is in place is actually um, going to do what you expect it to do. So it's a little bit like unit tests for infrastructure, except for that it is almost more of a functional test because you are physically spinning up the infrastructure and then running your tests against it. So in this case, you would be testing that a certain process is up and running and could be used, or that the correct versions of software is installed and that sort of thing, that everything is running and working. Um, this is awesome because you can then actually, beyond testing the code that you are deploying, you can also test the infrastructure that you're deploying, and you can make sure that the code and the infrastructure work well together before you ever put it out in the field. Chef is interesting because it allows you to maintain and manage the configuration of all your virtual machines that you have out in the field. Um, it is it basically works as a single point of truth. So your operations team, your developers, everybody have one place to look to know what's being installed on these different machines, and how they're being set up. Um, it's a good way for people to start looking into automation. This is kind of the first step. If you can start automating the way that your virtual machines are built, and your applications are deployed onto those virtual machines, everything else is going to get a lot easier. Chef obviously is not the only option, and none of these are the only options for these types of problems. These are just examples. So you could use Puppet or Ansible or Salt. Those are all viable for configuration managers. So Fabric, yeah, this one's a bit of a stretch to add. This one, pretty much, it is a command line tool that allows you to do some sort of application lifecycle type of stuff. So essentially, I was using it for packaging and deploying my applications. I did a lot of work previously on customer projects where I would write something for them and then I'd basically throw it over the fence to them and they would have to then run it. The problem with that is they didn't know how to deploy the code that I had written, and they didn't know how to do upgrades and that sort of thing. So I was looking for a way to basically package the way that I deployed the code into the code so that it didn't matter where the code went. How you deployed it would live with the code. And that's one of the reasons why I chose Fabric for a lot of those projects, because it allowed for you to have automation of deployment and upgrades and rollback and all that sort of stuff in place without having to rely on a third-party system, like a system that is like a central system, or a system that they would have to install into their infrastructure to manage it. It is essentially a self-contained system that allows you to manage deployments and revisions and such. The main reason why I'm bringing up Fabric is because I really want to illustrate the fact that any automation is better than none. So if you just need something simple and you need something just to get to start automating your development cycle, you're not too worried about automating the infrastructure yet. If you can start there and start to get automation in place in your development cycle, it is going to make a big difference for being able to move towards automating your infrastructure as a whole going forward. So here are some use cases. So here's an application lifecycle type of scenario. You develop the code, commit it into Git. Jenkins picks up the commit and it basically builds it, and then it tests. If the build succeeds, then it runs a series of tests on it, and once all the tests and validation is finished, then it will create a WAR file. Jenkins then pushes the WAR file to a staging environment and brings it up. Your staging environment now has the new code on it. You can then manually validate that everything is working as expected in your staging environment. And once everything is complete, you can pretty much just push it to production. Obviously, this is not the complete life cycle because we haven't automated everything here, but this is a start, and this is where a lot of people, a lot of developers will benefit a lot from just getting this far. Now, the next step is to actually automate your infrastructure as a whole. So in this case, we would be setting up a chef role for each of the different environments that we want to spin up. Then we'd use Knife, for example, to deploy the different configurations to each of the different environments that we need. And then basically Chef will manage what gets installed on those machines and make sure that everything is ready for the application. And in theory, it can install the application as well. You can also manage things like performance tuning and that kind of stuff centrally. So if you realize that, oh, my MySQL configuration for this application is not working well, but you have 30 of those nodes out in the field, then you can tweak the MySQL config, for example, on all those machines by changing it in one place. So now if you were to automate from end to end, you would basically develop your code, commit it into a code repo, and then have something like Jenkins pick it up and run, build it and run unit tests on it. And then you'd have something like Test Kitchen that would kick off and basically spin up the infrastructure and start testing and basically test on real infrastructure. So your code would then get pushed out to a new environment. That environment would have gotten spun up by something like Chef to make sure that the environment is consistent every time. The Test Kitchen would then test that environment to make sure that everything is working as expected. The code would be deployed out into this environment and make sure that all the unit tests and theoretically and hopefully functional tests are working well in this environment. And once all the functional tests pass and everything is good, you now know that not only is the automation for your software working well, but your software is also working, the automation for your infrastructure is working well, and the infrastructure as well. So you now have a complete closed loop on everything to know that this process is all automated and everything works. And so every time you go to deploy new code, you can run through this process, and it will test your application from infrastructure all the way through code and make sure that everything is going to work as needed. So this was a quick summary, and I'm sure that you're going to have questions, but you really have to just start playing with this stuff and really get going to really see the real power of it. If you do want to get in touch with us, hit us up on Twitter, or you can come to our company website and contact us, and we'll absolutely field any questions you have. Thank you for listening.